All right, we are good to go. Welcome everyone to my session, Failure is not an option. Durable execution plus Dapr is rocket emoji. I think we can translate it as amazing. Thank you for spending this half an hour after lunch with me. I think it's my job to keep you awake. Hopefully I can manage that. Let's get going. I think we are pretty much familiar with failure in IT, right? Failure is inevitable. I think everyone experienced it probably firsthand. Maybe we caused even some failures, I don't know, but definitely as end users, we probably are familiar with a lot of IT failures. Usually it's always DNS that's causing it. I don't know why. And maybe some of you are as old as I am and are familiar with this Windows XP message, information message, that says task failed successfully, which is of course a very weird thing to show to your users, but that's actually what this talk is about. Failure is inevitable, things will fail, so why not make sure things will fail successfully? So maybe we can even automatically recover, or maybe we can make the impact on the user as small as possible. So I'm Marc Duiker. I'm a developer advocate at Diagrid, a company founded by the co-creators of Dapr Open Source. I'm one of the Dapr community managers, big fan of pixel art, as you can see, also a big fan of VS Code. I'm running my entire presentation in VS Code. I will share a QR code with the GitHub link later, so you can definitely see all of the slides and all the demo code yourself later. So I did a bit of research about IT failures, and I came across this very interesting blog post. It's already quite old. It's from 2015. It's on the IEEE Spectrum blog post, but it describes lessons learned from a decade of IT failure. So it's quite a long blog post. I just took one screenshot out of it, but there's this legend, and the biggest circle is like 10 billion of monetary costs of IT failures. And here in this diagram, you see across like 2005 and 2015, across the whole globe, like very big circles. So you can imagine the monetary cost of IT failures is running in the hundreds of billions. And this was like 10 years ago, but I'm pretty sure that maybe the cost is even higher these days. So the link is all in here. You'll get the QR code later, so definitely check out this link yourself. It's very nice, and it's also an interactive blog post, so that's great. One of the reasons maybe IT failures are a bit more prominent is because also our applications are becoming more complex. So this is even not a very complex thing, but we are making more and more distributed applications, and services need to communicate with each other, either synchronously or asynchronously. There's lots of message brokers involved, lots of different state stores involved, and there's a lot of moving parts. So there's a lot of things that can go wrong, and of course that will go wrong. And that's nothing new, right? So who heard about the fallacies of distributed computing? Okay, so some hands. So this list of false assumptions is compiled in 1994, so quite some decades ago. So it's pretty much well known that distributed computing is hard, and that we don't understand everything when we start working with it. I'm not going into detail all of this because this is not really a theoretical session about this. I can definitely recommend you some of these links that I've included here, and one of them is like a playlist where Uri de Haan from Particular Software describes all of these fallacies in very short videos. So definitely have a look at that. Now, about 5 years ago, some smart people got together and created this open source project, Dapr, the Distributed Application Runtime. And over the years, it has been used by really hundreds of companies across all kinds of verticals to really help developers really run and build their distributed applications. So it really makes it much easier to build, but also run it at scale. Last November, it became a graduated project within CNCF. So, of course, the Dapr project is really proud to achieve that. And on the CNCF website, but also on the Dapr website, there's lots of case studies mentioned on how companies are using Dapr and how they use it successfully. So, if you have any doubts about Dapr, definitely have a read in these use cases. So, anyone familiar here with Dapr? Couple of people who's using it like in production right now. Okay, well, definitely stop by me later. So Dapr runs in a sidecar next to your application, and you can use any language since it runs in a separate process. And Dapr offers a lot of APIs that you can use as a developer to quickly build your microservices. Now, I'm not going to talk about all of these APIs because this is really a session about durable execution and workflow. Definitely, I recommend you, if you're new to Dapr, I can recommend you to try out Dapr University. I'm working on some educational content about Dapr now. I will also share a QR code at the end of the session where you can access this. It basically runs like a sandbox environment in a browser, so you don't need to install anything to try out Dapr. So getting back to the problem that we're solving, so we know that systems fail and we need to recover from those failures, ideally automatically, but also limit the impact of these failures. So, yeah, one of these solutions is durable execution. So durable execution means like running code in a stateful way, which sounds a bit weird, but we've actually doing that for quite a while. So in case the process that runs the code, if that process fails, another process can come up. It can read back the state because that state is persisted on disk somewhere, and it can then run the code to completion. Now, like I mentioned, maybe this durable execution term is maybe a bit new, but maybe you're familiar with workflow engines, and workflow engines have been implementing this durable execution stuff for many years. So who've been using like workflow engines in general to automate their business processes? Yeah, I see quite some hands, right? Yeah. So if you're new to like workflow engines and workflows in general, so a workflow consists of many tasks or activities, and all of these activities are like small units of work, maybe calling out to another API, saving some state to a database, or retrieving some state, publishing a message, and so on. So your workflow typically consists of all kinds of activities that make other calls and some business logic. And the way that workflow engines and durable execution work is because all of these state changes, they are stored to disk, to a state store. So I've created an animation just to give you an indication how this works in general, because there's actually a lot going on. So as soon as you start a workflow, the input of that workflow is actually stored in the state store. So there's a workflow ID and input that's stored. Then the first activity gets scheduled. Well, that first activity is then being executed, and the input and output is also stored in that database. So then we don't continue immediately to the second activity, but the workflow will start from top again. So it will read the state from activity 1. It doesn't execute it again because it's known that it already is there. Then it goes to the second activity, and again everything is persisted to disk. And again we replay from the top before we go into activity 3. So as you can see, there's a lot of I/O going on between the workflow engine and the state store. And yeah, this is necessary because a workflow can stop, can break any time, but all of your status workflow is persisted to disk. So this is in general how these workflow engines and durable execution works. Now, there are different ways how you can author workflows, right? So typically these systems started with Visual Designer, so you can more click and drag all of these workflows. There are also like step functions, which is more like JSON-based, but there are also like real workflow as code solutions. And I'm a big fan of these workflow as code solutions because it's part of your source control. So when you submit a PR with your changes, it gets reviewed by someone else. You can unit test your workflows, which is ideal because workflows should contain like business logic, which is quite valuable if that's correct. So I'm a big fan. So I have some examples of workflow as code solutions include temporal. Maybe people are familiar with Azure Durable Functions if you're doing serverless. Now, and Dapr Workflow is also like a workflow as code solution. So the Dapr Workflow API has been stable since the last Dapr release. So that happened in 1.15 in February, and it's been under development for over 2 years. If you want to know more about these durable execution engines, I also included a list to an awesome GitHub list that contains dozens of these different workflow engines, because there are much more out there. So when you start using these workflow as code solutions, you can use different workflow patterns with these things. So the most basic pattern that you can use is called task chaining, which is basically you run certain activities in a specific order. And you need the order because maybe the output of activity A is used as an input for activity B, and so on. So the order is important. Another pattern is the fan-out, fan-in pattern, and here there's no dependency at all between the activities. You can run them in parallel or in large batches. The nice thing about this, though, is that your workflow can actually wait until all of these activities are completed, and then you can aggregate over the results of all these activities. Another pattern is the monitor pattern, and this is great when you want to do like a reoccurring task. So maybe you want to run a nightly cleanup job in the cloud and remove some cloud resources. So the first thing that you can do is you can implement like a call to your cloud to clean up some activities. Then you can instruct your workflow to create a timer, wait 24 hours. The workflow will unload, it will not do anything. And then after these 24 hours, it will become active again, and then you instruct it to restart as a new fresh instance. So this is not the same as the replay behavior I showed earlier, because when you do replay, it will remember all of its history executions. But if you say continuous new, it's a new fresh instance. Final pattern I want to mention is the external system interaction. So this is great when you want to implement an approval workflow, for instance. So here you can instruct your workflow to wait until an external event comes in, and then you can use the payload of that external event to decide how you want to continue in your workflow. And normally you wouldn't use just one of these patterns in your workflows. You would actually combine several of these patterns. So this is an example where we use a bit of task chaining. We are waiting for an event. We also do a fan-in, fan-out one. And the nice thing, of course, if you use Dapr in general, you can use and Dapr Workflow, but also all of the other Dapr APIs in those activities. Then a bit about the Dapr Workflow engine. So the Dapr Workflow engine is part of the Dapr sidecar. So as soon as your application starts up and the Dapr sidecar starts up, there's a gRPC stream that's established between your application and the Dapr sidecar, because there are a lot of communication needs to be happening for scheduling your workflow. And your application itself will still run the workflow, but the Dapr sidecar is responsible for scheduling it. And in case it all goes down, the Dapr sidecar will actually start up your workflow again and will start executing all of these things. And of course, the workflow engine is responsible for persisting all of that workflow state to the state store and getting that back into your process. All right, almost time for our demo. So I have a demo with two applications, a workflow application that talks to an inventory, and I have a shipping application. And we'll do some kind of a simulation of an order process where we sort of validate an order and interact with this shipping service. Now this is what the workflow is doing. So the first activity of that workflow is an update inventory, where we actually check, do we have enough inventory? And if we do, we actually mutate that inventory. If we don't, we immediately exit. If we do have enough inventory, then we have another activity that gets back the shipping providers for this product that we're ordering. This gets back an array of different shipping providers, and then for each of these shipping providers, we will retrieve by making an API call to another service. Okay, give us the cost for this shipment. So this gives back like several cost indications. And then in our workflow, we have a bit of code that actually chooses, okay, what is then the cheapest shipper for this product. And then for the cheapest shipper, we will register this shipment. If this is all okay, then we end. If this is not okay, that means we can actually do a compensation action. So we can actually undo our update inventory again. And a compensation action is not something that is built into a Dapr workflow. It just means you write an activity to undo something that happened in an earlier activity. So we are actually undoing this update inventory when we call this activity. Okay, let's have a look at the code. In this code, in this case, I'm showing C#, but you can write your Dapr workflows also in Java, JavaScript, Python, or in Go. So in this case, we just have a class. We inherit from a workflow class that's given by the Dapr SDK. And we are running this method called runAsync. So the Dapr SDK gives us a workflow context, and we'll be using this context to call out and to schedule all our activities. We give it an order as an input, so that's our own object that we provide. And the output of this workflow is an order validation result. Again, that's just a custom object that we define ourselves. So we are using this context to call to an activity. So we instruct the Dapr runtime, okay, now run this activity. And as soon as the Dapr workflow engine will actually schedule this activity, this code will stop executing. It will be unloaded from memory. And once this activity code has been completed, then this code will actually start running again. So that's the replay nature I showed in the animation earlier. So we call an activity, and you always refer to activities by name. So in this case, we're calling the update inventory activity. We pass it a payload, and we get back an inventory result. And then we have just some if statements, which is our business logic. So if there's sufficient stock in our inventory, then we continue. The next activity that's called is getting the shipping providers. And here you see I'm adding in an additional argument that's called workflow task options. So you can actually provide a retry policy when you call these activities. I didn't do it in the first example here, but you can actually instruct the workflow in case this activity fails, retry it a couple of times. And in this case, it's just a simple constant retry policy, but you can also instruct it to do like exponential backoff. So that's totally up to you. So this gives us back an array of shipping providers. So what we're going to do next is we want, for each of these shipping providers, we want to ask them, okay, well, what's the cost of this of your shipment? So that's what's happening next. So we are iterating over these shipping providers in this for each loop, and again we are calling an activity get shipping cost. But notice that we are not awaiting this call here. So that means the Dapr Workflow engine is not actually scheduling these calls yet. We are purely adding these tasks here to a list. So this is a list of task of shipping cost result. And at this point, we are actually scheduling all of these tasks and also instructing the workflow here to wait until they have all been completed. So this is the fan out, fan in pattern here. So once all of these activities have been done, we just ask by, hey, give me the cheapest shipping service. So I just gives me the minimum cost here. So at this moment, I have a shipping service identified, which is the lowest cost. And then the next part is registering the shipment for this shipping service. Now I've wrapped this in a try catch clause just to indicate that you can use some other control logic inside a workflow. So I'm calling a register shipment activity here, but what happens if an exception is thrown in this activity? Well, we can then catch the exception. Exceptions are wrapped in a workflow task failed abstraction. In this case, you can of course always inspect what the inner exception is of this one, because this is a really workflow specific exception. But this is how, for instance, you can do determine if you need to execute a compensation action. All right. So if this call to this activity fails, then we are in this catch block, and then we do the undo update inventory activity. Yeah, so this is our compensation action. Right, just to show you an example of an activity, there are multiple activities, but I'm just going to show you one because they all have the same structure. Again, an activity is just inheriting from a workflow activity that's based on the Dapr SDK. In this case, the inventory is actually checking against a state store using the Dapr API, so that's why we're using the Dapr client here. We have a run async method again, which is being called, and we're using the Dapr client to retrieve some state. So we get back a product inventory, and we just check if do we have enough of this product in stock. If not, we of course give back a result that we don't have enough in stock. But if we do, then we make a mutation to this state, and we save this state again using the Dapr client. All right. Now this is the startup part of the program. So what's important for Dapr Workflow and what might be different with other workflow as code systems, you need to register your workflows and activities with Dapr, because otherwise, if you don't do this, Dapr has no clue that there are workflows or activities present in your code. So in this case, we need to use the add Dapr Workflow method on the service collection, where we need to register our workflow and our activities. Now, when I run the demo, I will execute this endpoint. There's a validate order endpoint, and what happens here? We are retrieving a Dapr Workflow client, and we are executing the schedule new workflow async method. So here we are instructing the workflow engine, please go ahead and schedule this new workflow. Again, you do it by name. So we pass in this validate order workflow. We provide an instance ID because each workflow needs an instance ID. If you don't provide one, it will just generate a GUID for you. But in this case, I'm just using the order ID as my instance ID for this workflow. And we provide the order as an input for the workflow. So notice that we don't get back the result of this validate order and for this workflow, right? Because everything is asynchronous. So what we actually get back here is the instance ID. And the instance ID in this case is exactly the same as the order ID. So I could have just returned the order ID here, but if you don't provide this order ID, then you need to get back this instance ID. Otherwise, you don't have anything to correlate to what correlates to my order. So we don't get back the result because we are triggering a potentially very long running process. In this case, it's very quick, but this could also take hours or days or months, right? So that's why you don't get back the result of your workflow, because everything is asynchronous. I have some other endpoints to update the inventory, but I think it's almost time to run the sample now. So as I mentioned, durable execution, workflow engines, state needs to be persisted somewhere. And you define what kind of state you use via component files, if you're familiar with Dapr. You define them in this YAML structure. So in this case, I am using a state store that's based on Redis, because if you use the Dapr CLI, you always get a local Redis container running. So Redis is where our state is stored, and you're not directly interacting with the state. We're using the Dapr APIs to interact with this. You're not interacting with the state directly yourself. Dapr Workflow is built on top of Dapr Actors. Again, you're not using the Actor API yourself when you are working with workflows. It's just something that is useful for you to know. And that's why you need to make sure that the Actor state store flag is set to true. So this is like a prerequisite if you want to use workflow. Right, just one more YAML file, I promise, and then we're done. I'm using Dapr Run to start up my services locally, and in this case, I have configured which applications to run in this YAML file. I'm starting up a workflow application, and I'm starting a shipping application. All right, so what I'm going to do now is I'm going to use Dapr Run. I'm going to use this command, but it's all scripted, so you won't see me typing. I just click a button and this will run. So this will run both applications for me. It will run the Dapr sidecar for me as well. So once this is running, I will use a REST client within VS Code to make a call to this validate order endpoint. That will start my workflow. Then I will stop all processing to indicate something severe has happened and our applications are crashing and burning and not alive anymore. And then I will restart the workflow with this Dapr Run command, and then we'll see what happens, right? Because we were actually aiming for like automatic failure recovery, right? Because that's what durable execution is offering us. All right, so I'm running the apps now. So now our workflow application is starting up. Now our shipping application is starting up. Also the Dapr sidecars are starting up. So everything is running now. Now let me make sure that we first have some inventory. So this is working. So let me check if this works. Yeah, okay, so I have like 5 rubber ducks in my inventory, so that's all working. Okay, so I'm now calling the validate order endpoint here, and this is my payload that I'm providing. I want to order 2 rubber duckies. Okay, so I am sending the request, and then I'll wait very briefly, and then I will stop everything. Yeah, I will stop right now. All right, so the last thing in our logs that we've seen, I mean, there's a lot of debug logging here, but the last thing that was happening is our workflow application was making a service call to our shipping application, and that's the last thing what's happening here. So this is a log from our shipping service that is going to retrieve the shipping cost for this order. But before it could return this information to our workflow, I've stopped all applications, right, to indicate something bad happened. So everything is down, workflow is down, shipping app is down. So let me restart everything again. So now I'm running Dapr Run again, which just starts up everything, and let's see what happens. Okay, and again we see that the shipping services are contacted again, all 3 of them now. And let's wait a bit more. And soon. Yeah, and now the cheapest one is selected, that's service B in this case, and now we see a log statement called orchestration status completed, right? So this is actually the Dapr workflow engine completing our work after a failure. We only need to start up the process again, which if you're running in Kubernetes will make sure you'll get a new pod and will start up everything again. But I didn't need to make a call to this validate order endpoint again, right? Because Dapr realized, okay, you have a workflow that is not completed yet, so let's run it again. And I can verify its state by making a GET request and with this instance ID to get back the state of this workflow. So this is the workflow, this was the exact instance ID that we did run, and this is the final state. This was the input, and this was the output. All right, so this is how Dapr uses the durable execution concept. Okay, let me stop executing this. All right. I will skip the next demo due to time, but I do have some other important parts to mention. Right. So workflow as code is great, or workflows in general are great, but there are still some challenges when you're working with workflows. So there are 4 points I want to discuss. These are all described in great detail in a blog post by Chris Gillum. I definitely recommend you to read this blog post if you're really seriously considering to use workflows. One of them is that your workflows should contain deterministic code. Let me zoom in a bit more. So why does your code need to be deterministic? Well, your workflow is being replayed several times, right? Yeah. So if during this replay your behavior changes within the workflow, this can cause a mismatch between the state that is stored and what's happening during runtime. Right, because after each activity call, all of the inputs and outputs of this activity call are stored into the state store. And during a replay, when some of these arguments change, there's a mismatch between the states, and then you have like a very weird mismatch between state and workflow. So what you should not do, for instance, is this: you should not use like GUID new GUID, which creates a new random GUID inside your workflow, or you should not generate a new timestamp in your workflow. And for these like common use cases, there are actually some helper methods on the workflow context called a new GUID and also context current UTC datetime. So there are some helper methods to make that a bit easier. If you have other code that is non-deterministic, just wrap that code inside an activity call. Yeah, because your activity code can be non-deterministic, that's totally fine, but make sure your workflow is deterministic. Now, your activities, Dapr Workflow guarantees at least once execution of your activities, meaning your activities can be executed more than once. Right, so yeah, what happens when you write your activity code, where there's like not a guarantee that there's different behavior in your activities. So for instance, what if you do an insert in a SQL store, and when you provide a primary key, so what happens if you do an exact same insert with that primary key for a second time? Well, that probably would not work, right? So you're probably then better off to do like an upsert, or you first do a read before you do a write. So yeah, you need to check what kind of code you're using. Other APIs, maybe the APIs that you're using are idempotent, maybe not. So you have to make sure that the code that you're using is idempotent. Another tricky thing with workflows is versioning. Basically, whenever you make a significant change in the workflow, maybe you change the order of the workflow, or you change some input arguments to some other arguments, that is a breaking change in the workflow. And it has to do with the difference in between state and what you're using at runtime. So for instance, I have this first version of a workflow, and that has the order item, which I'm getting as an input for my state. I'm using that as an input for both my activities. But then I change my mind, and the second iteration of this workflow is I'm using the order item as an input for my first activity, but I'm using the result as my first activity as an input for my second activity. Now, when I deploy this, and there are still some workflows in flight, meaning some uncompleted workflows, they have the state that belongs to this version, meaning they have the state that contains this order item as an input. But now my new code expects the result A, which is actually a completely different type. So that's a breaking change. So I think there are several workarounds to this. Probably the easiest is to just version your workflows, right? So, and here we see the workflow name has a number, version 1, version 2. Yeah, so never change a workflow, just always add a new one. It does mean that your client that's calling the workflow, that also needs to be updated, because your new version should now start calling this one instead of this one. But that's the easiest thing. Okay, final one, just make sure that when you are passing arguments between activities, make sure they are as small as possible. Because all of these arguments, they get stored to this state store. So in this case, we pass in an ID, which is small, which is great. We get back a large document from this activity, and we're passing this large document as an input for another activity right here. So that means that this document is saved twice in the state store. First, it's saved as an output argument for this activity, and it's saved as an input argument for this activity. So so that it's very inefficient. So in that case, don't make your activities very small and granular, and give a bit more responsibility to your activities. So just make sure, in this case, do both a get and an update and a save in one activity, instead of like making very micro activities. All right, my time is up. I hope I've shown you a bit about Dapr Workflow. I've got 2 R codes for you to share. So the left one is this GitHub repo where all of the slides are and all of the source code is. The right one is a link to Dapr University. You can use that if you're completely new to Dapr. But in a couple of weeks, I'll release a new lesson that's completely about Dapr Workflow. If you have questions, just come see me afterwards. Thank you very much.